All right, so we are here. This is me and Garrett, and so we are here to explain how solutions can be very important to your real life.
Definitions. Solution.
A homogeneous mixture of two or more substances.
Colloid.
A homogeneous mixture made up of particles evenly dispersed in a solid, liquid, or gas.
Suspension.
A mixture consisting of small particles that are kept dispersed by an agitation or shaking motion.
Miscibility.
Liquids with the ability of being mixed together to form one mixture.
Saturation.
When solutes are dissolved or dissociated in a solvent.
Solution.
Alright, so what we have here is we're going to take and make our own hot chocolate. So what we have here is we have this 2 cup of water right here, and then we have our hot cocoa mix, which we were going to take and make some delicious hot cocoa. So Garrett, why don't you go ahead and take this 2 cups of water and then come over here. There you go. Bring it over to my microwave. Pretty sweet, pretty sweet. Excellent, excellent. There we go. Alright, and we're going to set it for about 5 minutes. Alright, and we'll get back to you when it's all nice and ready.
Alright, now we put the cocoa in.
And this would be how much, Garrett?
That is 1/4 cup.
1/4.
And
so,
this is another 1/4, which equals 1/2 cup.
No way. That's
No
awesome.
way.
Alright, and now to make this solution dissolve even faster into its solvent, we're going to stir it up and give it a little agitation. Help it mix quite nicely.
Oh, very nicely.
Oh yeah.
Mm.
Nice dark brown.
Oh yeah.
Very nice, very nice.
Look at that hot chocolate. Alright.
Alright, so now that we've got our hot chocolate, we're going to go ahead and make ourselves a little batch. And there we go.
Boom.
Nice hot chocolate.
I would drink it, but I'm allergic, so
Alright, Garrett.
the ice cream didn't make me feel too great.
Alright, so here we are with experiment number 2. And here we have our 2 glasses of water, equally proportionalized, as I can see, done by Garrett. And we have ourselves some great value vegetable oil. That's what I'm talking about. And then we have great value. And now we have some red wine vinegar. So what we're going to do basically is we're just going to mix these two together and find the miscibility, or as we explained previously, the mixtures of 2 liquids, and to see whether or not they mix together. So Garrett, can I have you take the red wine vinegar and just kind of dab some in one of them. There you go. Alright, well, we kind of got a reddish mixture here. You can see that it's not quite a homogeneous mixture. You got a little hetero because you're able to kind of just determine which one is which. But all in all, it looks like they're mixing because in the end, there's no particles left over that subside that make it seem like we have a different. So now let's get the vegetable oil. Pour some of that in there. Oh, hey, look at that.
That was a
What
lot.
is that?
Oh, man.
Whoa, that is definitely some oil forming at the top. So we definitely have a non-miscible mixture right here.
Or immiscible,
Immiscible, as to clarify.
as it is correctly stated.
And make it seem so.
Suspension!
Alright, so we're back, and what we have here may seem to appear like a spoon, a glass of water, and a bowl of country crock butter. Well, if you look again, I don't think that's quite country crock. This, however, would be dirt. One of our great examples of how we can find a suspension in most mixtures would be a mixture of dirt and water. So, Garrett, would you gladly take the spoon and mix about, I'd say about 3 spoonfuls?
Or what about 4 heaping spoonfuls?
Okay, just do that.
Same amount as what we did in the sugar on our Kool-Aid.
Oh.
It's okay.
Yeah.
We got a paper towel.
That's
then.
why we brought the paper towel.
The paper towel.
There we go.
Oh, that is looking lovely.
Yeah, there's your suspension for you. Now, the definition of a suspension is that whatever is being put into, or the solute of this solution here, mixes, but to a point to where the particles still exist and the mass brings it down, and therefore it sinks. And so you get kind of this weird representation of what might look like chocolate milk, but actually might turn out to be, I don't know if you can see this, but they're kind of a gathering at the bottom where you can kind of see at the bottom where all the dirt has collected, and this would be a good representation of what a suspension is.
You know what's a colloid?
What?
Jello!
No way, dude. You know what I think is a colloid?
Aerosol! Woo! Yeah!
Oh my gosh, that's too much aerosol.
Definitely a colloid. That's a colloid.
Oh, that's a colloid.
That's a colloid.
But I actually think that a real colloid might be some shaving cream.
Shaving
cream. Shaving cream. You know what? Shaving cream.
Because the definition of colloid is a homogeneous mixture that. Well, I can't even talk, man. A homogeneous mixture that made up of small particles that is dispersed evenly throughout a solid, liquid, or gas. And obviously, as we see here with the aerosol, it's dispersing throughout this air.
Okay, yeah, I can see that. Just grabbing my flashlight here.
Whew! Alright. For real today, we got some Tyndall effect going on. We got our various mixtures here, and Joel's going to explain to you how the Tyndall effect works.
Alright, so basically we have all these different mixtures, and we have this beaming flashlight going through so that you can see all these shadows coming across on the wall. The first one we have is our constant. It's just basically some water so that you can see what it looks like in shadow form of how it should look on the back wall. So, first we have our water, and second we have our regular solution of just some water and some salt. So back here you can actually tell the difference that between water and the solution, that there's a little disturbance, but not enough. And so basically the Tyndall effect doesn't have any properties here, and so it's nullifying what it's showing. Another thing we have here is our little miscibility thing, where we mix vinegar and water, and where it mixed, and on the back wall you can see that there's actually no Tyndall effect going on, and so that it's basically not part of the Tyndall effect, and so we know it's a solution for sure. The next thing we have right over here is the fourth one, where we have our little suspension with dirt and water. And so inside you can kind of tell that it's not exactly clear, but if you look at the back wall, you can definitely see that over here in this area that it's not exactly clear, and you can definitely define that it's got some Tyndall effect going on. The last one we have is some shaving cream, which we have used for our colloid. And so if you look back here, the Tyndall effect is definitely going on here. You cannot see through it. So that's basically how the particles are disturbing the light coming through it and making the Tyndall effect work.
Oh, my swagger was too powerful for us, so we came down here to do saturation!
Alright, as Garrett just now proclaimed, we have come here to do saturation because previously we got stunk out of our old room. Too much power. So here we have our 2 solutions. We made some hot chocolate, and here we got the one that we originally made, and then I kind of spruced something up together, and that's what we got. So Garrett here, he went a little overboard with the heating. Like he used his own body temperature, and so as you can see, we needed a pad right here because it was just whoa, it was really hot. And you see, mine, that's the one I made. Yeah, yeah. I used my own body temperature, and that didn't work quite as well.
It came out just fine, Joel.
It was fine, but you know,
Mm.
I mean, like it. Garrett, he just used so much. He was able to get so much solute in there. It was pretty cool because like he heated it up, and for some reason there was more available. I mean, he was just so hot. Whoa, no, not that kind of hot. Come on, Garrett, come on.
Okay, fine. We're talking temperature.
All right. Yeah, we're talking temperature here, not body heat. All right.
Mm.
So there we go. We got this really thick, nice looking hot chocolate.
Mm.
And over here, I kind of heated it with my own body temperature. And so it might not have worked out as much. I mean,
That's.
you know.
I would not drink that.
well, I mean, I would, but
I would not.
you wouldn't? Really?
No,
Really?
because I got mine.
But I mean, it's really
All right,
good.
so this one right here, super saturated because of me. This one right here, well, as you can see, it's not quite saturated, which means it's unsaturated. Ladies,
Look at Garrett.
now look at Joel.
Now look at Garrett.
Now look at Joel.
If you think we explain mixtures to you better than your chemistry teachers,
You're probably right,
you know why you're right.
because we used Old Spice Swagger.